Professor Harita, and today we're going to be learning about, wait a minute, where are my team?
Oh, I'm Professor Vetter.
I'm Professor Jacob.
And today we're going to be learning about Newton's 3 laws of motion.
Why did that miss?
I know why. It's because of Sir Isaac Newton's first law of motion.
What is the first law of motion?
Well, there's two parts. The first part is an object in motion will stay in motion until acted upon by an opposing force. And the second part is an object at rest will stay at rest until acted upon by a force. But right now, let's just focus on the first part. So, while you were running, you and the ball were moving at the same speed. So when you dropped it over the target, it should have gone in, right?
Yeah.
But it didn't because the ball continued to move at the same speed because it was being pulled by that force. Hey, Professor Floyd, do you think I can flick the note card out from under the penny and the penny will land in the cup?
No.
Well, let's try. Wow, I did it!
How did that happen?
Well, it's because of Newton's first law of motion. Remember when we talked about that earlier?
Yeah.
Well, this time we're going to use the second part. An object at rest will stay at rest until acted upon by a force. So in this case, the penny was at rest on top of the note card. And then when I flicked the note card out, gravity acted upon the penny and the penny fell into the cup.
I don't get it. I used the same force for this ball as I did for this ball, but this ball went more farther. Why?
I know why. It's because of Newton's second law of motion.
What's Newton's second law of motion?
F equals ma, also known as force equals mass times acceleration, which means the acceleration is based off of how much mass the ball has, or the object, and how much force is applied to it. So the reason that the plastic ball accelerated more than the golf ball was because it had less mass than the golf ball did. Therefore, it went farther.
I get it now.
Here's another demonstration of Newton's second law of motion. F equals ma, force equals mass times acceleration. This time, I will push Professor Harita twice. One time with less force and one time with more force. When I push her with less, she'll accelerate less, and when I push her with more force, she'll accelerate farther. Now see, that was with the least amount of force, so she didn't go very far. So now if I push her with more force, she'll accelerate further. That was Newton's second law of motion.
Why did only two spheres move?
It happened because of Newton's third law of motion. For every action, there is an equal and opposite reaction. So in this case, the action was you, Professor Jacob, lifting up the first sphere, and it impacted on the middle spheres. And the energy traveled through them. Then the reaction was the last sphere lifting up and impacting into the middle spheres, continuing forever.
Oh, that makes more sense.
Oh. Why did I lose?
It happened because of Newton's third law of motion. For every action, there is an equal and opposite reaction. The action was my car hitting the button on your car. Then the reaction was the guy popping out of your car.
Thank you for watching. Where's my team?
Thank you for watching Newton's 3 laws of motion.
Hope you learned something.